Hello everyone, this is a snapshot video on Venn diagrams and how they're used for counting. You should be familiar with the following concepts from either lecture and or reading. You should have read over my Venn diagram lecture notes before attempting this. Here are the concepts you need to be familiar with. Set concepts, the idea of a Venn diagram and how it's used in counting, and the union counting principle. I'll remind you what that is. The number of elements in A or B is the number of elements in A plus the number of elements in B minus the number of elements in both of the two sets, right? Okay, that is the union counting principle. Now, we're going to walk you through some examples, but you should always stop the video, try the problem, then play the video. So our first example here. At a poll, we have a poll of 200 po' boy fans, and it was found that 126 eat shrimp po' boys, 120 eat oyster po' boys, and 50 eat both. How many don't eat either type of po' boy? Now notice what we're doing here. We have 200 fans here, right? And we are classifying these fans by either if they eat shrimp po' boy and or they eat oyster po' boys. That's the concept of a set. Sets take objects and they categorize them. That is, they label them, right? So we are taking 200 fans and we are labeling them with either shrimp and or oyster. The second thing we're doing is we're counting how many. When we are working with a set and we are trying to count, we are probably thinking in terms of a Venn diagram or possibly the union counting principle. Now, the world consists of 200 po' boy fans. The world is a rectangle, right? Since we have two distinct categories, shrimp, oyster, we're going to come up with two circles. One, let's say, for the shrimp, and let's say one for, I want a different color here. One for the oyster. Now, if you look at the numbers we're working with, we have 200 fans. The idea of a Venn diagram is to break up the universe into distinct regions. In other words, we have one region here that the shrimp people are broken up into. The entire circle is shrimp, but here are two distinct regions, one here and one there. Likewise for the oysters, they're broken up into two distinct regions, right here, and then we have this outer region, which is a distinct region, meaning there's no overlapping. Well, the 200 we don't know how to break up yet, because how many go in this region here, this region here, this region here, this region here. Likewise, the 126 that eat shrimp, don't know how to break them up right now. The 120 that eat oyster, again, we don't know how to break them up. But we do know where the 50 that eat both types, we know where they have to be. I just erased that, sorry. Again, this is unedited. And I have a erase button on here. But anyway, we know where the 50 people belong. They belong right there because they eat both. And if they eat both, they have to be in the shrimp circle. They also have to be in the oyster circle. So now I've taken care of the 50. Now if you think about it, 120 eat oyster, right? So in the circle that consists of the people that eat oyster po' boys, there's 120 people. But if I look, 50 people are already standing there, meaning I am missing 70 people. Those 70 people have to be here because they eat oyster po' boys, but they do not eat the shrimp po' boy, because we already know where the 50 people that also eat shrimp po' boy are located. Next, if you look at the shrimp, there's 126 people that eat shrimp po' boys. But if you look in the circle associated with shrimp, 50 people are standing there, right? Well, that means we are missing 76 people that eat shrimp po' boys. Don't worry about that. Again, you're gonna get, I don't edit my videos. 76, right? So 76 are right here. All right. Now for the 200. If you think about it, for the 200, that's the universe. But in my universe, I have accounted for 76 people. Okay. That leaves me 114 people, right? Okay. I mean 124 people. Now watch the math there. 124 people, right? I've also accounted for 50 people. Okay, that leaves me 74 people. All right, and then there are still 70 people I've accounted for. I am missing 4 people. Those 4 people have to be out here. So now I have my Venn diagram filled out. I can start answering questions. How many don't eat either type of the po' boy? 4. But notice what I did. I aimed for the number that I could locate exactly where that number appears. In other words, I can't work with a number until I know how it breaks up into the distinct regions. So we're going to move on to the next slide here. So a Venn diagram is a means of visualizing the relationships between the elements of 2 or more sets. Now there are 2 ways which we can utilize a Venn diagram. One in terms of the elements and where they belong, as illustrated in this particular Venn diagram. This is the one that I personally do not care much for, because if you have a whole lot of elements, how the heck are you going to fit them in this space, right? But let's not worry about it. Let's move on. Let's get an idea just in case you need to work with this. But anyway, this Venn diagram is telling us where elements are located. So the numbers in this particular picture represents elements, okay? That is, in the context of this problem here, this is not how many, it's what they are. If you look at it, the universal set consists of 8, 15, 1, 3, 6, 0, 4, 2, 9. If you look at this this Venn diagram here, A and B has a 0 and 4 in common. 2 and 9 are just elements of B. They're not elements of A. A union B, I'll show you this one. A union B consists of the elements 1, 3, 6, 0, 4, 2, and 9. Okay, so when a Venn diagram represents where elements belong, that's one method. But we're going to focus on the second method, where it is representing the number of elements and where they belong. As in this particular Venn diagram, where the numbers here represent how many. Just got to be aware of the context of the Venn diagram. So in this particular picture, we know that there are a total of 2, 5, 7, 9, elements in the universal set. That is, the number of elements in the universal set is 9 here. I'll just point out a few other things. The number of elements that are only in A, 3. Elements only in B, 2. Elements in A and B, 2. Elements in A or B, 3, 5, 7. Got it? Now we'll move on to working with Venn diagrams in terms of the number of elements. In the example that follows, just keep in mind, the important thing for us is a Venn diagram visually breaks the universal set up into disjoint regions. Regions that have no common members. This will help us when it comes to counting things because, one, we won't overcount because everything belongs to exactly one region. We won't undercount because everything belongs to exactly one region. Everything has a one and only one region it can belong to. So in the example that's following, we're going to have a Venn diagram. We took a survey and several people were asked, which of the 3 parades, Rex, Zulu, and Hermes, are you planning on seeing this year? From the survey, we came up with this Venn diagram. So, again, we took a group of people and we labeled them. We put them in a category. That is, we are working with sets. Second, we are counting. How many parades are you planning on seeing? Labeling, putting things into different categories. Also counting suggests the concept of a Venn diagram. So let's just look at this picture here right quick. Here are the distinct regions. I'm going to check them off. We have this region out here. We have another region right here. Another region right here. Another region right here. Another here. I'm going to run out of colors here. But here are all the distinct regions, right? And I think I didn't use up the colors. So each color, notice those are distinct regions, meaning if you're in exactly one and only one of these regions, there's no overlapping of the regions. Yes, the circles overlap, right? The circles overlap, but the regions don't overlap. So for example, this region right here, that consists of those who plan on seeing all 3 parades because they're in all 3 circles. This region right here, those are the people that are going to only see Zulu and Hermes because they're not in a Rex circle, right? This region here, these are the people that are only going to see Rex, right? So you got the idea? Let's move on. Let's work a problem. Okay, once again, you should be pausing the video and trying to work these problems out, all right? Now, for our above slide, here is the Venn diagram, and we're going to attempt to answer some questions. What number of people will see Rex? So they're going to see Rex. Well, if you look, these are the people that are going to see Rex because they are in the Rex circle. Since they're non-overlapping regions, we simply add these numbers together. 20, 30, 40, 42. And please, if I somehow mess up on my counting, just shoot me an email. You see a little mistake here, shoot me an email, please, because again, these are not edited, all right? So I'm trying my best to give you a hand here. All right. What number will see Zulu and Hermes? Okay, so we need to see Zulu and Hermes. Well, if you look in this particular video, Venn diagram, in this circle here that I'm forming, which really isn't a circle, but more looks like a football, if you're standing here, you're seeing Zulu and Hermes. If you're standing here, you're seeing Zulu and Hermes. So 16, right? So 16. Once again, it did not say you were not seeing Rex. That's the issue. Just because they're seeing Zulu and Hermes does not mean they're not seeing Rex. I said nothing about Rex. That's typically the mistake. So let's clear that one off. How many people were in the survey? Well, you just add up all of the numbers, right? So I'm going to do the math here, and I'm going to add them all up. So 15 plus 20 plus 10 plus 25, should have my glasses on, plus 10 plus 2 plus 14 plus 22, right? So I'm adding up all of these numbers, and I get 118 by adding up all of the numbers, right? Okay, clear that one off. The number that will see exactly one parade. Well, if you're standing here, you're only seeing Rex. If you're standing here, you're only seeing Hermes. If you're standing here, you're only seeing Zulu. So you add these up, 20 and 25, 45, 65, 67, right? So 67. Moving on. Again, hopefully you're trying this yourself. The number that will see only Rex and Zulu. Now you see that? We have a key word here. You know these people are not seeing Hermes. So you have to be in a Rex and Zulu circle. So you're in both of them. But the problem is these two people are seeing Hermes. And these are only Rex and Hermes. So only Zulu. Apologize, Zulu, 10. So the answer is 10. The number that will see none, well, that's what these 15 people are doing. I guess they're going to Disney World. All right, that's that. So we're going to move on to the next slide. Okay, here's another example. So again, pause the video and try to work it out. We have a survey of 120 people. 60 like math only, 30 only like English, and 10 like neither. So how many like both? So once again, we have a group of 120 people. We are classifying them. We are labeling them math, English, right? We're counting how many. We are labeling. We are putting into a category. We're counting how many. It suggests a Venn diagram. So here's my world. My world consists of 120 people. There are going to be those that like math. That's my math circle. There are going to be those that like English. Here's my English circle. And we overlap them because some might like both. So once again, I start with the 120 people. You might see where to start, okay? I'm acting as though I did not know where to start. If you know where to start, you go for it, okay? I'm trying to find a number that fits in exactly one region right now. The 120 can be divvied up into several different regions, right? I'll just mark them with a little green dot. One region, another region, another region, another region, right? I don't know how it breaks up. But when I look at the 60, they only like math. If they only like math, those 60 people have to be standing there. There's 30 people that only like English. Those 30 people have to be standing here. Okay? And then there are 10 people. They don't like either. So those 10 people have to be standing out here. So now I've worked with all my numbers except 120. If you think about it, there's 120 people in the world. There's one particular region missing, and that's what I'm actually looking for. The number that like both. Well, I already have accounted for 10 people. That's 110. I've accounted for 60 people. That is 70. No, I'm sorry. Not 70, 50. I've accounted for 30. So 50 minus 30 is 20. 20 people are missing. They have to be here. just because of the way a Venn diagram is constructed. So again, I went looking for the regions I could fill out, but I did not insert a number until I knew exactly how it broke up. Moving on to the next example. All right, here we have a survey that was conducted at Seafood City, which is looking mighty pretty, down on Broad in St. Bernard, right? Now, 34 customers were asked, which of the following were they planning on eating over the next week? Crabs, shrimp, or fish? And the following results were provided. So we have a whole list of numbers, and if you look, we're trying to count here, right? We're trying to count. Well, once again, we have 34 objects which are being labeled crab, shrimp, fish, and we're trying to count how many. So again, this suggests a Venn diagram. All right, so we have our numbers here. Again, we can't use a number until we know where it belongs. Well, I'm going to let this circle here represent the crab people. This circle here represent the shrimp people. And this circle down here, the fish people. Okay? 18 plan on having crab. The problem is these 18 people, I don't know why it's not changing color here for me. Where do these 18 people belong? Because the crab circle has 4 regions to it. I don't know how to break up the 18. The 20 that plan on having fish. Again, I have a problem here because I don't know how to break up the 20. If I have to break up a number into 2 or more regions which have no numbers in them, I don't know how to break it up. So I can't work with the number yet. So keep going down and keep thinking about this. Right now, I cannot work with any of these above numbers right here. But the last number here, and it just happens to be at the end, may or may not be that way. 10 plan on having all 3. If you're going to have all 3, you have to stand right here. That's where you got to be. So I've taken into account where the 10 belong. Now I'll start looking backwards. 11 plan on having crab and shrimp. Well, if you're going to have crab and shrimp, you have to be in one of these 2 regions, right? Right here and right here, right? Well, if you're having crab and shrimp, there's 11 people. There's already 10 people accounted for. I am missing 1 person, right? 11 minus 10, I'm missing 1 person. That 1 person has to be right there. Done with that number. 15 plan on having crabs and fish. Well, we have 15 people having crab and fish, right? Well, here's where the crab and fish people have to be located. Up between this region and this region here, right? These 2 regions of people having crab and crab and fish. Well, there's supposed to be 15 people there. I've accounted for 10 of them. I'm missing 5 of them. They have to be there. Done. 12 are having shrimp and fish. Well, if you're having shrimp and fish, you're either here or you're here, right? Once again, 10 of the 12 have been accounted for. I'm missing 2 people that are having shrimp and fish. They have to be standing here. Moving on. 14 plan on having shrimp. Well, if you're having shrimp, you have to be in a shrimp circle, right? So if we have 14 having shrimp, I've accounted for 1, 11, 13 people. Already 13 people I know are located in the proper region. I am missing one person. There's only one place that person can be. 20 are having fish. I'm running out of space here. I need to figure out how to just erase a piece here. Again, I'm learning this new software here. I have not found how to do it. 20 are having fish. You need to be in the fish circle. Currently occupying the fish circle is 17 people, meaning of the 20, 3 are missing. There's only one place they can go, so I know where they are, right there. 18 are having crab. If I have 18 having crab, squeeze it over here, well, in the crab circle we have 16 people, meaning 2 people are missing. But again, there's only one region left. Those 2 people have to be there. Now there's one region that's missing, and that is the people that are having none of them. I know there are 34 people, right? That is, my world consists of 34 people. I have accounted for 2, 3, 4, 9, 19, 21, 21 and 3. I've accounted for 24 people. So 10 people are missing yet. The thing is, there's only one region they can be in, so I know where those 10 people belong. My Venn diagram is now filled out. Let's start answering some questions. How many are having crabs or shrimp? If you're having crab or shrimp, let me get a different color here. You're standing somewhere up in here, right? I said nothing about fish. So crab and shrimp, or shrimp, I'm sorry, I'm sorry, messing up here. Crab or shrimp. So crab or shrimp, you're standing either here or in one of these regions, right? Crab or shrimp. Be careful. 2, 3, 4, 9, 19, 21. So 21 people are having crab or shrimp. Now, how many plan on not having fish? If you're not having fish, you got to be outside of this circle. You have to be outside of this circle if you're not having fish. And here's where you have to be careful. So sometimes, not saying I want to, but sometimes if I mess up, think about it. It's probably a common mistake that people tend to make. Don't confuse and or. Don't confuse or forget to include a certain number here. How many are not having fish? Well, 2, 3, 4, right? And a lot of people forget this one, 14, because they're not having anything. People tend to look in the circles. Well, sometimes the number outside of the circle needs to be included, okay? So you're not having fish, 2, 3, 4, 14. How many plan on having exactly 2? If you're going to have exactly 2, then you either are standing here, because this is exactly crab fish. Here, this is exactly crab shrimp. Here, this is exactly fish and shrimp. So those 3 numbers add up to 8. 5, 6, 7, 8. All right, it is 6 o'clock in the morning on a Saturday, so. But anyway, just let me know. I appreciate it. If you do see a mistake or you think I made a mistake, let me know, because I might not have, I might have. And if I didn't, then that's probably you thinking something wrong. So feel free to let me know, or if you have any questions. Thank you. I do hope it helps.